from the experimental study made by Hooke in connection with the extension produced by the load applied on the wire, Hooke formulated a law called as Hooke's law. The Hooke's law states that the extension produced in the wire is directly proportional to the load applied, but within elastic limit. Elastic limit has been already discussed in the previous lecture. The experimental setup was like this. He was having a spring, and with that spring a pan was connected. That pan had an arrangement for containing weights. At the end of the spring there was a pointer, and that pointer was touching a calibrated scale. When he added the weights, he saw the extension. When he added more weights, he saw more extension, and the difference between those extensions was the extension produced by the load applied. In that way, he formulated what is the relationship between the load applied and the extension produced. We can say that Hooke's law states that load applied is directly proportional to the extension produced. Later on, it was seen that Hooke's law was applicable to all types of deformations like elongations, twisting, bending. So this Hooke's law was updated to the stress is directly proportional to the strain, where stress replaced the load applied and strain replaced the extension produced. Now, to eliminate this proportionality sign, we have to introduce a constant of proportionality, and that was stress equals to E into strain. This E was called as modulus of elasticity. This modulus of elasticity, E, is equal to stress divided by strain. As we know that strain is the ratio of like quantities, so strain has got no units, so the modulus of elasticity has got same units and dimensions of that of stress. Units of Newton per meter square, and its dimensions are ml minus 1 t minus 2. Plotting a graph between the load applied and the extension produced. This is load applied and this is extension produced. As the extension produced is directly proportional to the load applied, so we are having a straight line graph. A straight line graph. That means if the load is increased, extension is increased. If the load is decreased, extension is decreased. The slope of this curve gives us modulus of elasticity. So E is equal to load applied by extension produced, and that is equal to stress divided by strain. As there is direct proportionality, we are having a straight line, and the slope of that graph gives us the modulus of elasticity.